One of the most important things about lab is to properly keep a notebook. There are many reasons that properly keeping a notebook is important. The first is to record all data that is collected so that it is not lost. If you collect your data on Post-it notes or on your hand or as little notes scrolled into the margins of your lab handout, it's easy to forget what those notes mean. Further, they're not necessarily going to be easy for somebody else to interpret. It's important that this data is recorded logically. In the 1800s, when astronomers were looking for new comets, one astronomer missed the existence of a new comet because instead of recording his observations clearly in his notebook in a table, he recorded them on bags of hair powder and whatever else he could find, and simply missed that he had seen this new planetary object moving through the sky. It's also important because after you leave a lab, others may need to duplicate your work, and they need something that's organized in a way that everybody can read it, not just made sense to yourself at the time you wrote it. Furthermore, one of the most important reasons of keeping a lab notebook carefully is that at the time of doing your experiment, your interpretation of your data may be different than it is later. This happened to me when I started a new postdoc, and I looked at the lab notebooks of the person that had before me that they had left. And when I looked at them, I noticed they had summarized all their data into experiments that had occurred at 2 weeks and 4 weeks after the initial event. But it seemed odd that on the 2 different times they had done their experiment, the data actually didn't look exactly the same. Looking at their notebooks more carefully, I found that in reality, the 2-week points were taken on either 11 days or 13 days. And when those dates were separated out rather than combined, we were able to find some real differences that had occurred over that very short time frame that we didn't really think would happen when the experiments were first designed. So because the notebooks were kept carefully and the actual dates that the experiments were done were clearly recorded, it was easy to reinterpret the data in light of the things that we learned at a later time. In addition, your notebook serves as a permanent record. As you're writing your notebook, you need to think about the things that make it a permanent record. As part of being a permanent record, it's written in ink only. When you need to correct a mistake, you cross it out with a single line instead of using whiteout. You will be using notebooks that are bound and that they have numbered pages that you will need to add the dates to and have your TA sign before leaving the lab. It's really helpful to us if you put your name, your drawer, and then a table of contents so that you can easily find the information in your notebook. Because of having a permanent record and a chronological record of the work that you've done in the lab, it's important not to skip pages. You may sometimes want to start your next experiment on the next page when you're done with an experiment, and you can simply clearly put an X through the extra white space to indicate that the rest of the work was not done at that time. Now, before you come to lab, you need to come prepared with your notebook. And in fact, you'll turn in the duplicate pages of your notebook to your TA as soon as you get to lab. At the beginning of each synthesis experiment, you want to write the title. For the first week, this will be the synthesis of salicylic acid. Underneath the title, you need to draw the overall reaction that you'll be doing that week, because as chemists, it's easier for us to see what's going on by looking at chemical pictures rather than needing to read a lot. Now you need to fill in this reagents tables. This reagent table summarizes the experiment that we were doing. There is a column for either the mass or the volume, the millimoles of the reagent that you'll be using, the molecular weights of the solid reagents, the densities of liquids, as well as the equivalents, which is something that we'll talk about later. You also need to think about any specific hazards of that chemical, which will be brought to your attention in the lab handout that you may need to look up this information. You also need to write out the answers to the pre-lab questions so that you are ready for lab. In lab, it's really important to include all the details of what you did in your notebook. The first thing you want to include is the times at which various things occurred. This is most easily done by simply writing the time at which that it is in front of every step of your experiment. This allows you to go back and make sure that things took the amount of time that you expected them to take. Because you want to be able to use your notebook to repeat experiments, you want to include a diagram of any new reaction setup, so you know exactly how you set up the equipment or the glassware for that experiment. After you've used the glassware once in that arrangement, you can simply refer to that technique and not need to redraw the diagram. We're going to be talking about soon what the variac setting is to set the reaction temperatures, but sometimes you use a thermometer to record the temperature. All of such measurements want to be included. You want to include the amounts of each reagent used, including the amounts of solvent, because this information could be used to go back and repeat the experiment exactly. And you want to include all of the observations. Anything that you might think, that you might want to ask your TA, if this looks okay, that's an observation about what the reaction looks at this time and needs to be included. This would include things like color changes or the formation of a precipitate. You need to include raw data, not just calculated data. This means that if you weigh crystals on a watch glass, you need to start by determining the mass of the watch glass, then put the crystals on there, and then determine the mass of the watch glass with the crystals and record both numbers and subtract them in your notebook. You want to include any characterization data that you obtained during the course of the lab. Note that while you want to make sure all these things are in your notebook, this does not mean that you need to copy the lab instructions verbatim. Some of the lab instructions are summarized in the existence of techniques, or can be better illustrated in your notebook by the drawing of a picture. Furthermore, we want to know what happened to you in your experiment. If something doesn't look right at the end, I should be able to figure out what went wrong by looking at your notebook only. And I can't do that if your notebook is simply a recording of what's on the lab handout and not an explicit example of what happened during your experiment. Finally, after lab, in your notebook, you want to calculate the percent yield of your reaction. This gives you some sense of how well the reaction works. If this percent yield is over 100%, it immediately tells you that the product can't be pure because you couldn't have generated more mass of the material that you made than what you started with. In addition, you want to include the characterization data. How do you know the compound is what you wanted? And include a brief sentence that says exactly why you think that the characterization data you obtained matches the experiments that you saw.